Hello guys, my name is Victor and today I'm going to teach you a few mathematics questions regarding line integrals. And just for your information, this is a part of my assignment, Mathematics 3 in Nilaya University. So without further ado, I'm going to just jump to the first question. The first question is determine whether the given vectors are parallel, orthogonal or neither. So we are going to check for orthogonal first because it's the easiest one. So if the two vectors here are orthogonal, their dot product will be 0. Else, dot product will not be 0. So let's find out. So we just analyze the question. So you just dot product. So u dot product v, okay, is equal to, so -3 over here and 4 added with 9 and -12 add with 6 and -8. Okay, and if you calculate and you get the answer as -168. So it's very obvious these vectors are not orthogonal. So just gonna type text here. These vectors are not orthogonal because their dot product is not 0. Alright. So the next condition for us to check is to check whether these vectors are parallel or not. So what we'll do is u equals to CV, because if they are parallel, C can be determined a constant, and the way we do it is -3 over here as u, 9, 6 equals to C 4, -12 and -8. And if you calculate, so we can just take any of these and just calculate. -3 equals to C4. C is equals to -0.75 or -3 over 4. So hence, and if you take the second one, 9 equals to C 12, and you get the same answer, C as -0.75, and the third one, 6 -C, sorry, -8, and you get C as this one, the same answer. So hence these two vectors are parallel. Okay, and now we'll move on to the part 2 of the first question, and still we will check for the whether it's orthogonal, parallel, or neither. So we'll check whether it's orthogonal first. So what we'll do is we dot product u and v, and what this gives us is equals to 1. So we just take I as 1, and here 2i, so we just put 2, added with -1, -1, and added with 2k, so it will be 2, and k will be 1. So we get an answer of 5. So very obvious, once again, it is not orthogonal. So write a text here. The vectors are not orthogonal because their dot product is not 0. Alright, so now we would like to check whether it's parallel. So what we'll do is u is equals to CV. So in this case, u is 1, -1, and 2. And we'd like to check for C, so we're not sure. And then 2, -1, and 1. So we'll take the first one, 1 equals to C2. So in this case, C is equals to half, 1 over 2. And in this one, -1 is equals to C, so -1 equals to C -1. So C in this case is 1. So from here, we can see that there's no definite answer for C, so the vectors are not parallel. Alright, so in this case, the vectors are neither orthogonal nor parallel. Okay, now we are in our last part of the first question, which is the third part. So we have these two vectors. So what we'll do now is to find the dot product to check whether it's orthogonal or not. So by the way, so in this case, we're not sure of the value of a. It's not an integer, so we just keep it as a, and dot product means over here. So it's gonna be -b plus b, now a, plus c and 0. So what this gives us is -ab plus ab plus 0. So as you can see here, negative ab and plus ab, they will cancel each other out. So, and that will leave you with nothing but 0. So in this way, you can tell that these two vectors are orthogonal because their dot product is 0. Alright, so that's all for the first question. Alright, boys and girls, now we have the second question, and now we have 3 coordinates. So the question is, find a vector orthogonal to the plane through the points P, Q, and r. Alright, so what we have to find is PQ, the vector of PQ, and the vector of PR, and the vector orthogonal to this point is actually the cross product of PQ and PR. Alright, so first, without further ado, let's look for PQ. Alright, so PQ is quite straightforward. So -1 subtracted with 2, so that will leave you with -3, and now 3 minus 1, so that will leave you with 2, and now 4 minus 5, so that is -1. Alright, you have your PQ vector now. So the next vector to look for is PR. So 3 minus 2, and that will be 1. 0 subtracted with 1, -1. And last one, 6 subtracted with 5, that will give you 1. Alright, so you have your PQ and PR. So what's next is to look for the cross product of PQ and PR. Right, now we're going to transfer PQ over here, right here. So -3, sorry, -3 to -1, and here is 1, -1, 1. Alright, so the way we do the cross product is, right, so we will obtain a vector as our final answer. So -3 with -1 multiply, so you get 3, and -2, the product of 2 and 1, so that will give you nothing but 1. The next one will be 2 and 1. Alright, so this is the cross product, and we are done with our answer. This is our final answer. Hey guys, now we are moving on to the third question, and the third question is compute the integration of x squared z ds, where c is the line segment from 0, 6, -1 to 4, 1, 5. Alright, so what we have to do in this question first is to find the vector between these two coordinates, 4, 1, 5, subtracted with 0, 6, -1. So, and that will give you this vector. Alright, so 4 minus 0, so that will be 4. And now 1 minus 6, that will be -5. And 5 minus -1, that will be 6. Alright, so this is the vector that you have. Alright, so we'll let one of these points, we'll let this point to become a point in our parametric equation on C. So do it here, 0, 6, -1. Alright, it's the same thing. This is the exact same thing as here at this point. Alright, and now the way we obtain the parametric equation is to add a function of t with the vector we have over here. Alright, the vector we have over here. So that will be 4, -5, sorry, and 6. Okay, and there you have it. We have our vector, so we have our parametric equation, And now we can conclude x from here. So that will be 0 plus t, and we take the first one, 4t. So 0 we can ignore, so we just have 4t left, alright? 4t. And for y, we will have 6 plus negative 5t, alright? So there is our 6 plus negative 5t, alright? In other words, it's 6 minus 5t. The next one will be negative 1 plus 6t, alright? That will be z. So negative 1 plus 6t. So this is our parametric equation, and what we need to do now is to find the limits of t. So the way we find the limits of t will be t, right? This will be the limits for our integration later on. So we can see here x is equal to 40 from our parametric equation, alright? So we have to, this equation has to satisfy the coordinate over here, 0 and 4, alright? So we can simply put x as first one is 0, alright, as 4t. So in this case, t will be 0, alright? The next case will be x equals to, this is the same thing, x equals to 4t, but now we have 4 as our x, so 4 equals to 4t. So t will be 1, alright? So there we have it, our limits. So t is from 0 to 1, okay? And so now we have our limits already. What we have to look for last is to find RT and R prime T, the magnitude of R prime T. So RT is simply all these values, the parametric equation, 4t, negative 6 minus 5t, negative 1 plus 6t, alright? So all these are our values. So 4t, sorry, so we put it as ijk for, I'm so sorry. For t I, alright, in the form of ijk. So next one will be 6 minus 5t j and plus negative 1 plus 6t, alright? This will be our k. So when we actually differentiate this function, we'll get 4. In respect of t, we'll get 4 plus 5, sorry, negative 5 plus 6, alright? So this is our r prime t. Notice that this is actually exactly the same as the vector over here, alright? Now we just have to square root, alright, sorry. Alright, square root over here. So 4 square, 4 square plus negative 5 square, because we are looking for the magnitude, so we have to square root. The last one is 6 square. Alright, and you get an answer of square root 77. Okay, So this is the final answer for r prime t. Alright, so now we move on to the differentiation part, sorry, the integration part. Alright, so I already listed everything here. So you have your parametric equation over here. Alright, and now we have our integration. Alright, this is the question itself. So we put in the limits of 0 to 1 from the t, and we actually substitute 4t into x. So we get 4t squared, and we have a z function here, so we just put -1 plus 6t over here, -1 plus 6t. And what we have to do is to multiply r prime t when we change the sign to dt. Okay? And to further simplify our integration, we get 4t, so when you square it, it will become 16 square. So sorry, it's supposed to be a bracket over here. Alright, a bracket over here. 4t square will become 16t square minus 1 plus 96t cubed. Alright, I'm so sorry, it's not t. Alright, so further on, we'll move on. So when you actually integrate, you'll get this answer. You can remove the 77 because it's a constant, and your integration answer will be this: 16 over 3 t cubed plus 24 power 4. Alright, and from the limit to 0 to 1. Okay, so there's a negative sign over here. Okay, and if you continue to solve this, continue to solve over here, you get root 77 56 over 3. Right, and that is actually 163.8. Alright, so this is the final answer. Okay, so we'll move on to the next question. Okay boys, now we are in question number 4. So suppose an object moves from this coordinate to 2, 4 along the path RT subject to the force given by the function x sine y and y. Find the work done. Alright, this question is a little bit more trickier, but if you understand the concept, it will be much simpler. Alright, so first off, they have already given you RT, which is t squared. So what you need to do is to just write down the parametric equation over here. So xt is simply t from this equation, t, and yt is simply t squared. Alright, on there. So yt is simply t squared. Alright, and what you need to do next is just to find the limits for t. As you can see, xt is simply t. So this means that x must be t. So you can simply take the limits of -1 to 2 as the limit for t. So t will be -1 to 2. Alright, it's very important. And next, we will find the differentiation of RT, which is R prime t. Over here, so the differentiation of t will be 1. Alright, and the differentiation of t squared will be 2t. Okay, so you have your all your values set up, and now we'll move on to the integration. All right, so to integrate the work done, what you need to have is this formula: f dot product r prime, and the integration of this dot product will be your final answer. Okay, so I've already written here the values of f, which is the equation from the question itself, r prime t, which we found just now, and the parametric equation of x and y over here. And now what we need now is just to substitute all these equation into this big equation over here. All right, so if you substitute everything, you'll get this one. Okay, so the limits will be -1 to 2, and this will be, keep in mind this is a dot product, so we have to keep the vector. So t sine t square is from x will be t, and t square move into y, so you get t sine t square, and next one is y, so we just put t square and over here, and 1 common 2t is basically r prime t. Here is r prime, and next if we continue to dot product, we will get this equation over here. All right, so this t sine t square multiplied by 1, you get t sine t square, and t square multiplied by 2t, you get 2t cubed, and you add them together, you get a dot product. So we move on with the integration. All right, if you integrate t sine t square, you get -1/2 cos t square. All right, okay, the way I got this is by using u let u be t square. All right, let u be t square, and so your du dt will be 2t, and your dt over du is basically 1 over 2t. Okay, from here we can simply integrate by substituting this dt over du, 1 over 2t. Keep in mind there's a t over here, this t. All right, so you get cancelled off by the t down bottom, and sine, instead of t square it becomes u now. All right, du. All right, so next when you integrate this, you get the integration of sine will be negative cos, and you have half over here, so -1/2 cos u, and when you substitute u with t square again, you get cos t square. All right, so this is the integration part, and when you integrate 2t cubed, it's just straightforward, it will become 1 over 2 t to the power of 4. All right, with the limits of -1 to 2, and if you calculate this, you'll get the final answer of 7.5. All right, so there you go.